Hi, welcome to another lecture of JS Yatra, and in this lecture we are going to make a Tic Tac Toe component. The level of this question is hard, so without wasting any time, let's get started. Show you what we are going to build today. So this is how our final component will look like. You can see that it is a very nice looking table, and you can hover on each cell item like this, and the background color is changing. At the bottom you can see that the name of the player is shown, whose chance it is. For example, the current chance is of X, so it will show that current player is X. Once you make a move, let's suppose I make the move, then it will say that the current player is O, so the chance is now for the player O right now. So if I make a move again, then my current player changes to X again. So if I do it like X, then O, then X, then O, then X and O, and you can also see that you cannot make any changes on the cells that you have already voted for, or which you have already played. And if you continue doing this again and again, and let's suppose I make some random move over here, and I make the final move over here, you can see that the player O wins the game, right? And now I cannot click anywhere on the board is kind of become inactive. And also it is stating that who has won the game. And to refresh, there is no actually a reset button, but yeah, you can refresh this and the game will be reset from start. And yeah, and the board size is highly dynamic, so you can pass any number of the board size and it will adjust itself accordingly. So these were kind of the basic requirements, and obviously we'll be using the best design practices to make this component and make the solution fit for a perfect machine coding round. So yeah, let us now dive into the code and let's see how we can make this. Alright, so we are here again on the code sandbox, and let me gain some space. And I actually don't need this. I'll get rid of this styles later. But right now, my prime focus is to focus on the component. The app is going to have actually only one thing, that would be the Tic Tac Toe component. So it would be our Tic Tac Toe component. Okay, this is a self-closing component, and this Tic Tac Toe component is going to take the board size. Let's suppose I pass 5 for now. And also I forgot to mention one more thing, that the current version that we have implemented in the Tic Tac Toe, only the horizontal and the vertical rows are counted for the win situations. We are not dealing with the diagonal ones, okay? Because obviously the question is pretty big in itself only, and it is if you are able to cover even the horizontal and the vertical one, that is more than enough for you to clear the round, because ideally diagonal ones will take a good amount of time for you to accomplish it. And the question is also even not asking you to consider the diagonal scenarios. So we'll make this tic-tac-toe game fit only for the horizontal and the vertical cases. We'll be skipping on the diagonal cases over here. So that was the thing I missed telling you before. And coming back to the code, we have this tic-tac-toe. Although component is not defined, we'll define that in a moment. But it will be taking a board size, and it will be taking the cell JSX. So cell is nothing but whatever these boxes you are seeing over here, so these are the cell items. And as a developer of the tic-tac-toe component, if someone else is using my component, I want to allow them to use their own version of a cell component with different design system. So keeping that thing in mind, what I'll do is I'll allow the developer to pass the JSX of the cell as a part of the design system. So cell render would be over here like this, and it would be taking up a function. And again, what we are going to do is we are going to render the cell over here like this. Again, cell would be a self closing component, and this cell is going to take a good amount of parameters. For example, it is going to take, since we are going to map over the cell items, so it will be taking a key. And you can also notice that there are cases of where the cell is becoming disabled after it is having a value. So we'll be needing a one more param, that is a cell disabled, and we'll be needing the cell index. I'll tell you what the cell index is, and we'll be using a mark, and we'll be using a on click here as well. So let's get them running over here. I'll tell you what these things are in a moment, but let's just have them written over here. Okay, and now let's create our tic tac toe. Tic tac toe.jsx, and this would be our functional component. Const tic tac toe equals to a function default tic tac toe, and it would return us a nice looking div. Hi, something like this, and let us import the tic tac toe from /tic tac toe, and we also need to pass the cell component, so we'll be creating a cell.jsx, and let us copy everything over here and make it a cell, and we have the cell component ready as well, and we can just import it. All right, so everything is fine now, right now, and now let us write the tic-tac-toe functional component. Coming back to the parameters, again we discussed up till cell disabled, and regarding the cell index, so you can see that all of these items are basically array items. Okay, and these are having some indexes 0 1 2 3 4 and so on. So that index is being represented like this over here. Mark is like whether it will be an X, whether it will be an O, so this is the mark. And on click is again a function, so whenever you are clicking anywhere on the board, so you are triggering some function. To handle that, we are having this on click function over here. So now let us create our tic-tac-toe component. Our tic-tac-toe component is actually taking only two props. One is the board size and the cell design system. So board size, will take it like this, and we are also going to take up the cell render. Okay, so let us come to the very basic requirement first. You can see that first of all we have to create a slate or the board for us. So to define the structure of the board, it is really going to be very simple. You just need a board state like this, set board, and it is going to be use state. All right, and inside the use state, since we are having board size as a number, we have already seen that how we can create array from just a single number. It would be array dot from, you pass the length as board size, and please keep in mind that if the board size is 5, then there are going to be 25 cells in the table. So because there are 5 rows and 5 columns, so to cater to that request, the length should not be just board size. Instead, it should be board size multiplied by board size row into column, because the board of the tic-tac-toe is always n cross n. So the number of rows are equal to the number of columns, and that is how the board is created. So the length of the array is going to be n cross n. So we are actually going to have 25 array elements. If the if the board size is 5, then n cross n, 5 cross 5 becomes 25. So we'll be having 25 board items right now over here. And also we should fill them with null. Yeah, we should actually fill this with null. Why? Because we actually need a state to determine that whether the array element is empty, or is it having any item. So this particular cell is having item 0, but this particular array item is empty, so it is null actually. So that is why we are going to fill this with null over here. And we also need a state to determine that which player is playing. So if it is X playing, if it is the O0 oth player playing, right? So to determine that state, we have to create another state variable, that is X playing, set is X playing, and by default the first chance is of X, so it is going to be true. So if X is playing, then it is true. If X is not playing, then this is false, which means that player O is playing. Okay, so and if there is a winner, we also need a state to determine the winner. Winner, set winner. This is going to be null. So if there is no winner, it is going to be null. If there is some winner, then it is going to store the player's name. Okay, and based on that, we also need to determine the player mark as well. So we need a const player equals to if X is playing, then it will be X. Otherwise, the player playing is O. Okay, this is really very simple. Okay, now we have to get rid of this hi over here. So writing the JSX, now we don't need this div, we need actually just the fragment over here, and we need a div for the board. Okay, this is the div that will contain the whole board for us. And now you have already guessed that what we are going to do over here. We are going to map over this board.map. We actually don't need the item because it is filled with null right now. And after that we need the cell index. Okay, so we get the board, we are mapping over the board, and what we do is we have already passed the cell component, the cell design system, as a prop named as cell render. So we are going to call this cell render method over here like this, and this cell render method is giving us a lot of highs, but again we have to make it pretty and look good as well. But before that, this cell render is also receiving some props. Okay, so we have to pass these functions as well over here. So the first thing, this cell render is needing a key is going to be index, cell index. Next item it is expecting us is if it is disabled or not. So if there is any item, then it is going to be disabled. So now we need the value of the array item. So we can write it like as item over here. And what we can do right now is we can consume this thing over here. If item is not equals to null, or winner is not equals to null. So if this situation matches, then it is going to be disabled. Why this situation? Because a cell would be disabled only if it is containing some value, which means that the value is not going to be null. And the another condition that the cell is going to be disabled is in the case when we have a winner. So if there is going to be a winner, then the cells are also going to be disabled. So now coming back to this, we have written the same thing, that if the item is not equal to null, then please disable it, which means that it is containing either X or O. Or if there is a case of winner, then please disable this as well. The next value it is going to expect is the cell index. So cell index is same as over here. And the next param is the mark is nothing but the value that this particular cell is having. So it will be item. And the next thing is on click function. So on click function is going to be a function like this, and we can create a function const handle cell click, going to be a function like this. We will complete this function later, but for now let us have it like this. Okay, so we have the cell ready for us over here, and we are having some states as well. Before moving forward, it is really very important that we design these cells properly. So we'll be writing some code to make it pretty. And also, since we are going to create the board as well, so we are going to use the CSS grid properties. And if you are a candidate and if you have watched this GS Yatra episode, then definitely you are going to use and understand grids in this particular question. But other candidates are definitely going to use Flexbox. And this is the point where you are gaining upper hand than the other candidates. So trust me, 80% of or the 90% of the candidates are going to use the Flexbox. But since you are a learner of this course, you are learner of JS Piatra and JS Cafe, you are going with the right approach. Because why we are not using Flexbox? Because again, it is very hard to maintain such boxes. You can look at the complexity that these are many boxes, and it is really complex to get it done by Flexbox. But with grids, you can already see that it is just nothing but it is a kind of a grid only with rows and columns and having each items. All you need to define is the number of rows and number of columns, the height and width of each cell, which will be determined by cell once we create the rows and columns in the grid. And once you define the height and width of the whole container, you are good to go. So grid is like you will be just writing 3-4 lines of code to get this UI done in a very easy manner, and it is going to be very understandable as well. So please don't go with the Flexbox approach. It is now very outdated and most of the people are switching to grids now. So we'll be heavily using the grids. Flexboxes are only okay for the very simple scenarios, right? But for the complex one, we definitely go with the grids, and we can already see that it is a table using rows and columns. Then rows and columns automatically should ring a bell in your mind that okay, I have to implement a UI that is containing rows and columns. Then grid is the perfect solution for it. Okay, all right. So coming back to this, like how we will write the grid is very simple. We are having this style.css file over here. So we'll not be importing this in the app file, but we'll be having this in the Tic Tac Toe file only. And in the Tic Tac Toe file, we just need to define our grids. So this is the board. Board is going to be a display. Okay, so we have made it as a grid, and we also have to determine the rows and columns. So grid template rows, and we are going to do a repeat. And each row, so initially I want to hard code this value. I'll say that I'll be having 5 rows, and repeat these rows as a 1FR unit. So 1FR is like equally divide the rows in whatever space it is there. So and same would be for the grid template columns. Repeat 5 1FR. Okay, you can see that it is looking really nice. If you are not aware of the grid columns, like, so if you go to grid CSS MDN and you open this part, you can get the basic understanding of how grids are working over here, and it has a great tutorial as well. You can refer to MDN, but for the basics you can see that you define the grid, you define the columns. So if you need to define the columns, for example in this example they are having 3 columns of 200 pixel 200 pixel 200 pixels. You can see that they have created 3 columns, and whatever items fit in that content are fitted, and the rest are shifted on the new row automatically. So even in our case, if we define just the columns, Okay, it is going to be fine, right? But it is always good to have the rows as well. And since you can see that 20 pixel is being repeated 3 times, so what you can do is you can utilize this repeat property. So I want to repeat this property 5 times, and the size should be 1 fr. 1 fr means that it is distributed equally, or you can define your own size as well, like 200 pixels or whatsoever will be the value. So, yep. So this is the 1 FR unit that I was talking about. In addition to creating grids using length of percentage, we can use 1 FR. 1 FR unit presents one fraction of the available space in the container to flexibly size a grid rows and columns. All right. So coming back to this part, we have this value as 5, 1 FR, 1 FR, and 1 FR, and I want the height to be let's say 300 pixels and width to be 300 pixels. Okay, this is looking really better right now. Now coming back to the cell, we also want to write the css for the cell as well, because I don't want this height to be there. I want proper buttons and the lines should be there. So the part of board is over. Board just had to create the grids. Now it is the job of the cell to make things render inside each cell over here. So first of all, we'll write the JSX. Okay, so this particular cell is going to accept mark. It is going to accept cell disabled and on click. And since these are clickable items, then ideally we'll be using buttons. Now this is again a point where you are getting upper hand than rest of the candidates. Most of the candidates are going to use a div and they are going to add on click on that div element, and this is where the interviewer is going to get slightly demotivated, and they'll try to prefer you over them. Because why? Because we are going to use buttons. So every time there is a clickable item on the screen, it is a very good idea to use buttons and not divs. Okay, why buttons? Because again, they support aria nomenclature, that it will, if it is a clickable element, then if someone is using a screen reader, the screen reader is going to tell that okay, this is a clickable item, and buttons are going to get focused automatically as well. So over here we have this thing. Okay, we have this cell over here, and what I can do is I can leverage on this thing and get rid of this div over here and write a button. Okay, you can see 1 second. Okay, so we are getting buttons, so we can see that these are the buttons over here. And let us write some css as well, because it is not looking good right now. Last name, it will be cell, and disabled property is going to be cell disabled. Okay, and on click is going to be on click like this, and we are going to render the mark over here. All right, so we got the basic things, and we just need to write the css. So I'll be creating a file called as cell.css, and this is going to be a cell. Right, and over here let me just write the css properties that we are going to use. And so the cell is going to have a background color of white, the border is going to be 1 pixel solid gray, the color is black, the font size is 20. And when the cell is disabled, and it is when the cell is not disabled, and it is going to be a cursor pointer, but the cell is not disabled and we are hovering it, it is going to be having a background color of this. Okay, so right, so we have to just import this style over here. Import dot slash cell.css, and boom, you can see that it is looking really okay right now. and you can see that once we click on it, we are actually not seeing anything because we have not written the handle cell click function to get the things done. The main logic is still missing. But before moving to that part, there was one requirement that I can increase the board size to any number I want. So let's suppose if I increase it by 10 and I refresh it, you see that the UI got broken just now and it is not very much scalable. So how can we fix that, and what is the solution for it? So the solution is really very simple, that inside the board, you are hard coding the rows and column values. All right. So first thing is that, let's suppose if you are having five items in a row and you are saying that width is 30 pixels, 300 pixels, sorry. The each item is approximately going to be 60 pixels in height and width based on the numbers we had. So instead of assigning height and width over here, what I can do is I can just write 60 pixels, and I can just write 60 pixels here again. And this is exactly the same thing we are achieving if we are getting rid of height and width over here. But again, this is not solving our issue because we have to every time hard code this value, and we have to update this value every time when we change the board size property over here. So how can we do that? The solution is the CSS variables. So if I just create a root variable and I say that the board size is 5, okay, and if I, by default, this is a fallback value for any CSS variable, and if I write var board size, and let us just copy it over here, so you can see that this thing is getting updated. So if I just update this variable to 10, it is going to be just perfectly fine. This is what we wanted. But we have to update this variable from JavaScript, and based on the parameter of the board size we are receiving. So to do that, we have to create a ref variable. I know that, I am pretty sure that if you have watched the other videos where I have used the CSS variable thing, this is going to be really very easy for us right now. So what we need is, we need a board ref. This would be use ref, and I pass the ref over here like this. And based on the understanding, what do you think that you are going to use? Are you going to use effect to update the CSS variable, or you are going to use the use layout effect to update the CSS variables? Think about it. So we have already discussed this before also. Like if you are updating the CSS variables, then you have to do that before the painting happens on the screen. What is the accurate hook to achieve this thing? The accurate hook is to use layout effect. Let me take you again on this use layout effect. Use layout effect is a version of use effect that fires before the browser repaints on the screen. Okay, so what is the usage? For measuring the layout before browser the repaints the screen. So if you want to make any calculations that should happen before the painting is happening on the screen, then you definitely have to use the use layout effect. So I definitely want to fix the size of the board before the board is actually being painted on the screen. So the best thing to use over here would be use layout effect. We write it like this. All right, and I do is, so we copy the ref and I say board ref dot current dot style dot set property, and we pass the variable name, and we pass the value is board size. All right, the value is board size, and I just update the board size over here. So let us copy this and paste it over here. You can see that it is looking very nice. Now if I just close this, and if we go to app.js, and if I just update it back to 5 and I refresh it, you can see that it is looking really nice this time. This we need to just refresh and it is going to be perfectly fine. So you can see that we have determined a way to dynamically update or render the table, we can pass 7 as well. And if I refresh it, you can see that it is working fine as well. This is breaking because the code sandbox is not able to update it properly, but if you refresh it, it is working perfectly fine over here. So we have determined the board size over here, and it is looking very nice already. The main thing missing right now is the logic to update the variables. So now let us write the logic for the handle cell click function. The handle cell click function is going to receive a cell index. It is going to receive a player. It is also going to receive the board size. Why we are passing these things via the params? Why? Because obviously we'll like in the later part of the video, when we'll be optimizing this particular code, we'll be using use callbacks. And when I'll be using the use callback, the problem with that would be that we'll be having many additional player params and the board sizes in the dependencies. But yeah, I can definitely remove this for now, and to make it more readable to you, I can go with this cell index approach. So obviously when you are calling this function, all you need to pass is the cell index. Cell index we got, and what we want to do is so whenever any user is clicking any cell, I am passing this cell index. Now this cell index has to be filled with a particular mark. So what we will do is, first of all, I'll create a copy of the board, because we don't directly mutate the state arrays. We first of all create a copy, and obviously what we are creating a shallow copy, because it is a single dimensional array. It is not a nested array. Okay, that is one thing that we have to take care of. Why? That is, we have already discussed in shallow copy and deep copy in the previous lecture. All right. So first of all, I'll create a board copy equals to board. I created a copy, and I update the board copy index, board copy, the cell index, and the value should be player. Okay, I update the field, and I set the board with board copy. I updated the board in the 3 lines. I updated the board. Now in the next part, I have to change the player as well, because once you click on any item, you have to change the player to another person. So set is explain, and I write previous state and not of previous state. Okay, and we also need to determine that if it is a case of winner or not. So instead of determining winner on every re-render, it is very much optimal to determine winner on each click. So whenever I click any cell, I should be able to determine that, okay, if I click the cell, whether if there is any winner or not. If I click another cell, then I have to check again that if there is any winner or not. So we will be having a set winner function like this, and it is going to be a lot of logic that we have to write. So we'll cover this thing in the later part of the video right now, but for now let us see that if this thing is working fine or not. So let us refresh, and I click it. You can see that I got X over here, but I am unable to update it again. If I write it here, I am seeing O. If I write it here, I see X, O, X, like this. Okay, and I am able to fill all the cells over here. So this is working fine as expected, but again, it is missing a lot of things. We have to determine the case for the winner as well, right? And this is a place where we are going to write a lot of stuffs. So to determine the winner, because it is going to again be a lot of code, we definitely need a util file for it, util.js. So in this util.js, we are going to write the util function, the logic that is going to determine the winner for us. So let us create the function determine winner. Okay, and this function is going to take the board, okay, the whole board array, and we have to determine the winner on each cell in item click. So if I clicked on this cell, I should check that when I click this cell, so in this particular row or in this particular column, whether there is a case of winner or not. Okay, I have to check rows and columns that are only corresponding or that are only connected to this particular cell item. So the row is this and the column is this if I click on this cell item. So I will be passing the index, and also I would need to pass the board size as well, board size, because I don't want to calculate the length of the array when making computations. So when you click on this particular element, you determine that on which row and which column it is, and that is very simple. So if I write const row, this is going to give me the row index, math dot floor index divided by board size. So let me tell you how this is working. So mat.floor, what it does is, let me get you the definition. Mat.floor static method always rounds down and returns the largest integer less than or equal to the given number. So if I write mat.floor 5.95, it is going to give me 5, or if I give 5.05, again it is going to give me 5. So it always rounds down. Okay, so in this part, when I come to the question, so I am doing mat.floor index slash by board size. So for simplicity, let us update the board size to 5, okay, for easier calculations. So if I am clicking this particular cell, okay, this is cell index. Okay, the index is going to be what? 0, 1, 2, 3, 4, 5, 6, 7. So the index is 7 over here. Now if I want to calculate the row, the board size is 5. Okay, so if you do index divided by board size, which is equivalent to using 7 divided by 5, it gives you around 1 point something something, and if you round it off, it gives you 1. So the row value is 0, 1. So this is 1th row. Okay, this is the accurate number. Now if you want to calculate the column index, column, so if I write it col, so you will do index remainder board size. How is this working? Again, so index is, for this example, the index is 7 and the board size is 5. So if you divide 7 by 5 and you get the remainder is actually 2. You can do the math obviously. So the remainder is 2 over here, and the column index is also 0, 1, 2. Okay, so we get this thing, we got the row number, we got the column number, and once we get the row and the column number, what I can do is, for this particular row, I can make an array of all the row items, and for this particular column, I can make an array of all the column items. How do we do that? It is really very simple. I make const row items. It is going to be an array, and to fill this particular array, what I need to do is I need to make a simple for loop, let I equals to 0. So we'll run over the board size again and again, because if the board size is 5, then there are going to be 5 items in the array, and in the 5 items in the column as well. So definitely we want to run the loop 5 times to fill 5 items inside the row item. Okay, so if I equals to 0, I less than board size, I plus plus, and row items dot push board, and now if I just write row multiplied by board size plus I, then this is going to make sense. How it is going to make sense is really very simple. The board size is 5, the row value is 1, so 1 into 5 gives us what? 5. Okay, so you are accessing the board at index value 5. So 0, 1, 2, 3, 4, 5. Obviously you are at this particular item over here. Now if you increment it by 1, you get to second. If you increment by 2, 3, and 4, and so the value of I will be from 0 to 4, and row star board size will help you skip all the items in the first row, and if you just increment the item by 1, you are going to get all the items of this particular row. This is for the row items. In the similar fashion, we are going to compute the column items. So const call items is going to be an array, and I'm going to copy this stuff over here. But this time, instead of row items, I am going to push it in the column items, and the logic for the board is going to change a little. So let me write the logic first so that it will be easier to explain you. So I multiplied by board size plus column plus col. Okay. So how is this working? Again, this is really very simple. So if you are taking this example again, so the column value is 0, 1, 2. Okay, the column value is 2. Now if you want to fetch this particular value, if I multiply I with board size, this gives me 0. Okay, 0 multiplied by anything gives us 0. And I just added what I just added the column index, so it is 0, 1, 2. So I got this particular value. Now all I need to do is, once I get this particular value, I have to jump 1, 2, 3, 4 and land onto the fifth item over here. Okay, so I am just moving one row below. I am keeping the rows, I am keeping the column same. So it is like if I just do if I just do it like this, what I am doing is I am accessing the each row value. So if I am at if I am at this particular thing, I cross board size. So I is nothing, I is just the row. So I can replace it by row. Okay, this I is nothing but just a row. Okay, so I am at the first row, so I am getting this particular value. Now if I increment it by 1, so I am doing 1 multiplied by board size gives me what, 5. So I do it like, now if I am changing the row, so I am at the row index 1, which is the second row. 1 multiplied by 5 gives me 5. So 0, 1, 2, 3, 4, 5. So I am over here again. So if I increment the row by 1, then I come here, then I come here, then I come here. So let's suppose I am at this particular index, and I want to jump to this particular column. All I need to add is the column index, right? The only gap between this and this is the column index. So if I just write plus column, that is going to work very fine for me. All right, so I got the column items, I got the row items, and what I can do is, since I am going to check this particular row and this particular column, and the checking condition is going to be the same, so we have to run those checks on these two array items. So what we can do is, I can make a variable const lines and add row item over here and add call item over here. Okay, and then I can iterate over these two array and apply a common logic. Okay, so if I just do for const line of lines, okay, this is a line, so row is this line, column is this line, so it is a line item. Okay, so we got the line. All right, now what should be the scenario to check the winner? It is very simple, that if all the row items are either filled with X, if all the rows items are either filled with O, or if all the column items are filled with X, or if all the column items are filled with O. This is the only case for winner. All right, and how to determine if it is not a winner? If the row item is containing null, so if there is any row that contains a null, then definitely there is no winner for us. Okay, or if this contains a null, then there is also no winner for us. And also there is one more case that we have to, so having all the items of a row filled is not the valid case. Okay, they should be filled with the same element. Okay, this is what we have to check. So if I pick this particular item from the array index, now I am expecting that all the items present over here are filled with X or O, depending upon what we got from the first index. So that is what we are going to do is, I am going to get the value of the first item of the line. So I am getting the first item of this particular line by player. Okay, and I say line of 0. Okay, and if player is null, then continue. Okay, then what by continue I mean, that is we can we don't have any winner in this particular line because the zeroth index was itself a null value. Okay, so there was no winner, for example, for the row item. Then you continue to the column item and see if it is there or not. Okay, so if player is null, then there is no point in checking the winner. There is obviously no winner, and we can skip to the next line. If the player is not null, then we have to check that if this particular player, if the player we fetched is a winner or not. So const is player winner. And how we check that? We check that in very easiest way. We are using array dot every. And how is that working? So line dot every item, and I am checking that the item should not be equal to null, and the item should be equal to player. Then this is the only case of winning. Okay, and what it is saying? Oh, it is shall be and. So if you are not familiar with every, okay, let me take you array dot every in method in JavaScript. Go to MDN. So every method tests whether all the elements in the array pass the test implementation by the provided callback function. So if I am checking in this function that if this is the array 0, 30, 39, 29, 10 and 13, and I'm checking that is below threshold. So if every item in this array is below 40, then return true, otherwise return false. This is what we have to check. So I created a function that is going to accept individual array item, and it is checking this array item against a value. So if this array item fulfills, if every item, listen to my words carefully, if every item is fulfilling this condition, then it will return true. So you can see that every item in this is less than 40, then it is definitely returning true. And if I change this value as 41 and I run it, it will return false. Okay, so this is the power of every. It is exactly the use case we wanted. I want to check every element if this is equal to the player item or not, and it should also be not null. So if everything passes, then we definitely have a player. So what I can do is, if is player winner, okay, if is player winner, I can do is I can return the player. Okay, so I am returning the player which is the winner. If this is not the case, if player is winner is not the case happening, then I have to return null. Okay, there was no winner. So this was the logic for determining the winner, and we also have to export default determine winner. I am also fetching this function over here. So we are fetching import determine winner from /util, and inside the set winner function I am calling this determine winner because determine winner is going to give me the winner value. Okay, and what it was expecting us, it was expecting the board. Okay, I passed the updated board, so I have to pass the board copy and not this board value. Why? Because we have updated the state just above. Okay, and since the state update is asynchronous, we are not sure that whether the parameter which we are passing over here is going to receive the latest value of the board. Okay, so we are having the board copy already over here. We can pass this board copy, and it is expecting the index. So I am passing the cell index, and it is expecting the board size. So I am also passing the board size over here, and this will check that if there is winner or not. So we obviously don't have a case where we are showing the user if there is winner or not, but let us check that if I am having a winner, then I shouldn't be able to click any other item. So if I have x0, 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 x and 0, now you can see that all the items on the slate got disabled and I am not able to click anywhere. That means that we definitely had a winner. So we want to show a message to the user that there was a winner. So we can create a function and say get message. okay, like this. And this function is not there, and what it is saying that get message is not defined. Obviously it is not defined because I have not written it yet. I can write the function over here. So const get message is going to be a function. And what are the cases that we are going to check in this function is going to be really very simple. First of all, we are checking that if winner is not equals to null, then definitely we had a winner. Then return saying that player winner is the winner, or is the winner of the game. This was the case to check the winner. And what if there is a draw scenario? So there is a draw scenario as well. So draw scenario is the case where you have filled all the cell values and there is no winner, so it is a draw. So you can check that if not board dot includes null. So if the board does not includes a null, then it means that all the board items are filled, and since we already have checked the winner, so if board items are filled, there is no winner, then this definitely points to the case of draw. So we can say return it was a draw. Okay. And also if these two cases are not matching, then definitely it is a case that where their players are still playing the game. So I can say that return current player chance is of and I write player. Okay, you can see that the current player chance is of or the current player is, I can remove this, current player is X, current player is O, current player is X, right? So let me check if this is working or not. X O X O X O X O X and O. Player O winner is the winner of the game. All right, let us check the draw situation. It is a draw. All right, this is working fine, and you can see that current player is also changing like this. Yep, and if I write it like this, player X is the winner of the game. So this was we have written all the logic, and it is now time for us to optimize it a little. So first optimization that came while writing the cell was that you can see that there are many cell items which are not getting updated. So we definitely do not want to re-render these cell items whose props are not changing. So I can do is I can wrap this cell item inside a memo like this. Okay, I can wrap this in a memo so that all the cell items whose prop was not updated, they do not get re-rendered. Only if the mark cell disabled or on click changes, then only they will be recreated. So this was one optimization we talk about. If you're not aware of memo in React, I can quickly go through it. React.dev memo lets you skip a re-rendering a component when the props are unchanged. This is really very simple. And what are the usage are skipping re-render when the props are changed, updating a memoized component using state, updating memoized component using context, minimizing prop change, and specifying a custom comparison function. So this was the cell thing for us. Now coming back to the other part, you can already see that we are using a map and we are calling these functions. Okay, we optimize this thing. The only thing I think the only part we are missing is adding use callbacks. Okay, and this is the part where we'll see that how we can reduce recreation of the variable handle click again and again. So first of all, let me just add a use callback over here, and I added it like this, and see what are the dependencies it is asking me to update. So it is asking me to add dependencies like board size, player. Okay, 3 dependencies. And can I reduce it? Yeah, I can. So if I pass the board as a param, and if I pass the player as well via the params, now the dependencies, all I have to add is the board size. Okay, I can pass the board size as well, and you can see that it is not taking any other function. So we need to pass those things. So I pass the board in the function call. I am passing the player in the function call, and I'm also passing the board size, okay, in the function call. And you can see that now this function will be created once only, and it will not be recreated on any of the re-renders because the dependency array is empty. And if you're not aware with use callback, I can take you to use callback. Use callback is a React hook that lets you cache a function definition between re-renders. So these are the dependencies array. If any of the dependency array gets changed, then this function is recreated in the memory and stored in the cache again. But if there is no dependency array, then it means that this function is going to be created once in the re-render and it is being cached in the memory. So we are saving a lot of browser space. Okay, that is one good optimization we are doing. So we already have used the use layout effect. We have to also memoize use callback. So I'll add get message function over here, and I will write it inside this, and it is asking me to add board, player, and winner. I think we definitely want to recreate this function because we are displaying the values. So we are having winner, we are having board, and we are having the player. And what else are we missing? Okay, we added memo, we added use callbacks, and let's come back to the board size. Okay, so I think we have finished this question in just time, and let me just recap everything that we have done. So first of all, I created the Tic Tac Toe component. It received two props, that was board size and the cell render. Cell render is part of the render design pattern, okay, render props design pattern which we are using. So you have to speak about it. Many of the candidates are not going to use this cell render thing. They are not going to use the render design pattern. They are directly going to import the cell inside the Tic Tac Toe, and they are directly going to render it over here like this. But since you are a learner of JS Cafe, you are not doing that mistake again, and you are getting an upper hand in the interview by using the render props method. That was one thing. So we have been solving a lot of machine coding questions, and we have been seeing that render prop pattern is coming again and again. So make this as a habit of yours to think about the various design system before writing the component. Okay, so we have got this design pattern over here, and inside the Tic Tac Toe, we made this component fit to any board size by using the CSS variables. So over in this part, we were updating the CSS variable based on the board size, and it dynamically updates the size of the board. Okay, we do not have to update the CSS value again and again. That was another thing. And also we use the used layout effect. Why we used? Because we wanted to make the complete the UI, complete the layout of the board before the repainting happens, before the painting is happening. I want the layout of the board to be ready. This is why we have used use layout effect instead of use effect. And this was again a moment where you gained upper hand from rest of the candidates. Okay, because you were using a good thing. The interviewer will get shocked. Okay, he was able to think about use layout effect in this interview. He is definitely a pro person. Okay, that is why I am talking about heavily on the optimizations, even in the machine coding round as well. We have talked a lot. We will be talking, if you have watched the system design videos, then we have talked a lot of things about the optimizations, and we are again talking about optimizations in the machine coding round as well. So we updated the CSS variable property via set property. Then we have created the board over here like this. We iterated it. And then we have created all the states as well. We learned that how we can create an array just from an integer value. And then we created various states. Then we also created the cell. In the cell component, we added a memo. That was a very good optimization because we didn't wanted other cells to get re-rendered again. That was one good thing. Another thing which will uplift you in the interview was using the buttons as a clickable items, because most of the candidates will use a div button for this thing. But if you are using a button, you are again setting your benchmarks in the eyes of the interviewer. Okay, so this was about the cell thing, and we have written some good css as well about the cell. And yeah, and in the board styles we definitely use the grids, and we did not compromise using flex boxes. Okay, so why we were using grids? Because we can definitely see that it was a case of rows and columns, and whenever there is a scenario of rows and columns, grids fit perfectly in that scenario. And we made this grid very dynamic as well. You can see that it was dynamic, and it was expecting the size of the rows and the columns was fixed as well, and the number was coming from a variable. And then we created a util file to determine the winner, and we heavily used good data structures here as well. Why? Because we were using this every function. So if you use every function, then again you are setting benchmarks in the interview, because not everyone uses every. Either they use the map, or they use filter, or some other stuff. But we went with the array.every approach, which just fits our requirement. Okay, so this was and also we created a util file. That is again a plus point for you, because what most of the candidates will do is they will write all of this function in a single file, and the interviewer will get confused and they'll say, okay, this code is very messy, I am not able to understand anything. We have created a util file where you are importing all of the codes into the Tic Tac Toe component, and you are using those util function here nicely. Okay, so this was all about the Tic Tac Toe component. I hope you liked what I taught in this lecture, and this was all in this lecture, in this video, and see you in the next one.